So we come to one of the critical issues that we mentioned earlier about nulls and exception handling. The presence of nulls in your code and the idea of exception handling. So this is just introductory, but it's the concept and what's going on here. So the easiest way is to demonstrate this and discuss it in demonstration. So in my code here, let's just push this down. In my code, I created 3 objects. At the moment, they're not linked to each other. Their linked nodes are null. Now, what happens if I had written this code? I defined a stack node as a temporary node to get hold of. If I said to SN1, get me a linked node, right? Now that line of code would, if there's nothing there, return a null. So theoretically, temp will just store a null. Shouldn't be any real problem at that stage because, of course, it can be null. But this is where it gets really interesting. If I do a system out dot print line and I say to the temporary node, actually I'm missing a couple of member variables. I need a get ID. So let's just come back to stack node and let's get an ID. We're not going to set it, we're just going to get it. So we just need a getter for the node ID so I can display it. So I'm going to go to my generate, I'm going to get a getter and just for the ID. So there's my get ID, right? So let's come back over here. So if I come to my temp and I click there, I should be able to get the ID, right? Let's close that. So look at these lines of code. So I've created 3 objects. They all link to nothing at the moment. And this is just to demonstrate a concept to you. I create a reference and I grab hold of the linked node from any of them. It doesn't matter because they're all essentially the same at this stage. That won't necessarily throw a wobbly because it will just pass a null back. But if I try here to display the ID of the linked node, then clearly something's going to go wrong. Okay, so let's just run it and watch something go wrong. Now this repeats some of the material that we have covered. There we go. We've got what's called a null pointer exception. Now I'm hoping you're understanding what the word pointer is doing in here. This does go back all the way to C, and it says, well, you can't get the ID because there is no object there for that method to work. It's a null. So it's an exception. You have just broken your code. So the easiest way to kind of manage it is to do what's called a try catch block. So you take the risky line of code and you do narrow it as much as possible down to it. And you simply catch it. You can do something with it. This is going to be a null pointer exception, let's just call it NPE, and perhaps even see what it would display, right? But it's not actually that important at this stage. It just stops our system from crashing. So if I ask NPE, get me your message, tell me what happened, right? So that's a very simple, using an inbuilt exception handler, and we know that that's the right one because that's the one that's been thrown. Let's run it and see what happens. Give it a second. There we go. That's all it tells me. It's null. This is why later on you will be doing custom exception handlers to add more information to help you understand where the issue is. Remember, with objects, you can have objects within objects, objects inherited from objects, linked objects in a linked list, and objects can hang off those, and it can be incredibly complicated structure, right? Just having a message back to your client say there's a null is not very useful. So we will come back to that at a later stage. But that is a very simple and obvious mechanism and also a simple explanation.